Hello everyone, I am Soham Chari and I am here to present our work Elections in Twitter Era Predicting Winning Party in US Elections 2020 using Deep Learning. The co-authors of this paper along with me are Rashmi T, Hitesh Mohan Kumain and Hemant Rathore. First of all, I would like to thank HIS 2022 for accepting this paper and allowing me to present our work. We start off by introduction, followed by literature review and contributions. Then we propose our framework, the experimental setup and results, and finally we conclude with comparing our work with existing literature and conclusion. So, for political events such as elections, it is very crucial for us to understand the public opinion and the nationwide opinion. Hence, we conduct election surveys and polls. However, these are extremely expensive and time consuming. Hence, we need alternative methods to understand these opinions. So, we move on to social media platforms such as Twitter. Now, the United States has the largest Twitter user base in the world, with 46% of its users using Twitter daily. Hence, it has become a hub for people to express their political leanings and opinions. Analyzing such a large amount of tweets of political events can help us understand and predict the election outcome. So, initially, this has been tried out using word counts, like frequency of the occurrence of the word, highest number of tweet mentions, etc., can be used to predict elections. However, these approaches miss the vital contextual and semantic information present in our tweets, and hence we need advanced approaches that interpret these meanings. Now, previous works such as Hidayatullah et al., Liao et al., and Shia et al. Have performed Twitter sentiment analysis using ML and DL techniques. However, one thing that has been missing in most of the previous studies is they have only used positive sentiment tweets, and we believe that even negative sentiment tweets play a crucial role as important as the positive ones in political events such as elections. Also, they have used a limited number of tweets and no prediction or information has been given on winning margin. Hence, we propose a framework to predict the winning party of US elections 2020 and the corresponding winning margin using the multiple deep learning approaches. We also propose a net score metric that uses both positive as well as negative sentiment tweets to find a winning party. And in addition, we perform weather-based analysis to predict the winning margin, which is found to be very close to the actual election results. Now, this is our framework. Uh, for the data set, we have considered US 2020 election tweet metadata. This data set consists of tweet IDs, the party to which the tweet belongs, that's positivity, negative sentiment score, and so on. So, since the actual tweets were not available with us, we used the Twitter API to extract the tweets from Twitter. We extracted around 6 million tweets. Most of the tweets have were non-English or missing important information or having unimportant columns or rows, etc. So after pre-processing, this resulted in 1.5 million tweets. Now, since we cannot feed the textual information directly to the models, we perform data transformation to convert our information into numerical vectors, and we use Glove word embeddings. So Glove is basically pre-trained word embeddings that have been trained on large amount of textual data. Finally, we perform tweet sentiment classification using our three deep learning approaches: bidirectional LSTM, CNN LSTM, and GRU. We also perform weather-based sentiment analysis to predict the winning margin. So moving on to our experimental setup, the first one is our bidirectional LSTM classifier. So here we show the architecture followed for bidirectional LSTM classifier. We had an embedding layer followed by a stack of two bidirectional LSTM layers, followed by a dropout layer as acting as a regularization parameter, and finally a fully connected linear layer with output as three neurons representing our three classes: positive, negative, and neutral. The second approach is our Vader-based analysis. So Vader algorithm is a dictionary-based approach. Hence, it refers a lexicon database to give a sentiment score to each tweet, which we call as cumulative score. Then we use cumulative score to calculate something called as marginal gap, which we use to predict the winning margin. We also perform polarity analysis as our results show further. So now in sentences, the local information is quite important and CNNs have been found to be useful for that. Similarly, even the long sentences, the information in the long sentence is also important, where LSTMs have been found to be extremely useful. So a hybrid CNN LSTM works quite fine. So our architecture follows embedding layer followed by two convolutional blocks, followed by a bidirectional LSTM layer, and finally we have flattened fully connected two linear layers. Our final deep learning approach is the GRU classifier. We followed the same approach as the bidirectional LSTM, same architecture, except that instead of bidirectional LSTM units, we had GRU units. GRU has been found to be a memory optimized version of LSTMs, and hence we have tried it out. Finally, we evaluate model performance using various metrics such as accuracy, precision, recall, F1 score, and RSA score. We also calculate the compound sentiment score, which is obtained through Weider analysis. We use this CS score to get the marginal gap, which is finally used to calculate the winning margin. We propose the net score metric, which uses both positive as well as negative tweets for calculating for predicting the winning part. So moving on to our results, we show that our model performance shows that bidirectional LSTM approach outperforms other two approaches in all metrics with giving highest accuracy of 95.99%. Now, since it performed the best, we also use it to predict the net score, calculate the net score. So we find that Democratic Party has a net score of minus 0.0767, higher than that of Republican Party. So this basically shows that since it has higher net score than the Republican Party, so we conclude that Democratic Party is likely to be the winner of the elections. Moving on to our weather-based descriptive analysis results. So we calculate the average compound score for each of the parties along with some other labels. We can see that the Democratic Party has a positive average compound score compared to Republicans having negative score. When we use these statistics to compute the marginal gap, we found it out to be 6.25%, and the margin of vote count observed in actual elections is 4.54. Hence, our results are pretty close to the actual election results. We also consider retweets since retweets show how further the tweet has traveled through the Twitter community. Hence, when we consider tweets, we also see a wide gap between Republicans and Democrats when we consider retweets. So the same gap can be seen as well. Finally, I would like to compare our work with existing literature. So I would like to make a few points here. First thing is that to get results close to actual election results, it is very important to have a large tweet volume. Hence, we have used 1.5 million tweets. So second thing is that our performance, the accuracy obtained from our approach is the highest, which is 95.99%. Further, we use both positive as well as negative sentiment tweets to understand and predict the winning party. And finally, we predict winning margin of 6.25, which is the closest in comparison to all other previous works when we compare with it actual election results. Finally, we conclude that sentiment analysis using a large volume of election-related tweets can help us in predicting election outcome. So we analyzed 1.5 million US election 2020 tweets and predicted the winning party and the corresponding winning margin. We built distinct deep learning approaches as well as one dictionary-based approach. Our bidirectional LSTM model achieved the highest accuracy of 95.99%. We proposed a custom net score metric that uses both positive as well as negative score negative sentiment tweets, and we find out that Democrats have a higher net score. Finally, we use weighted-based analysis to calculate a winning margin of 6.25%, which for Democratic Party, which is very close to actual election results. So these are all the references that we are citing in the presentation, and thank you.